Okay, so I hope you. Okay, so tell me, how is the day going for you all? Is it good? Okay, so today we are going to explore a new chapter, right? And I'm taking the reference of the Hayes book, okay, for MYP 5. And this new chapter is known as the quadratic equations. We're going to explore this chapter, okay? And meanwhile, we're going to explore first, we are going to revisit some old concepts to understand some parts of it. Okay. So let's just start with this. Okay. I hope you can see my screen clearly. Okay. So the very first part, okay, we will come back to this open-ended problem. Okay. But in the past, we have solved many equations of the form ax plus b is equal to 0. Now, if you just remember, these type of equations from a straight line, and hence they are known as the linear equations. Okay? Moreover, they have only one solution, right? Now, uh, for example, an equation like 3x minus 2 is equal to 0, when we just eliminate 2 on both the sides, right? We get 3x is equal to 2. Okay. Moving forward, we will get x is equal to 2 by 3. So moving one step ahead, right? We have another form of equation, which is known as the quadratic equations. Now, a quadratic equation is the equation which can be written in the form of ax square plus bx plus c, means in this form. Okay, where a, b, and c are constraints. Okay, are constants, whereas uh, there is a special condition that this a, the coefficient of x square should not be equal to 0, because if this becomes 0, then basically we are just talking about a linear equation. Okay, a quadratic equation may have one, two, or no real solutions. Now we will talk about this real solutions and how to find this. But I wanted to recall this part, what a solution of an equation means, right? Okay, so when we say that x is equal to 2 is a solution, what it means? That means 2 is on the line or on the curve. Okay, so we'll talk about the quadratic equation graphs in a bit a while. Okay, how the graph of the quadratic equation looks like and how it works to be. Okay, but for here, just take a small example of x square plus 3x minus 10 equal to 0. Okay, so if I just want to show you how these things actually work, okay, so we'll move on to a blank page here. Okay, and let's understand. So for solving a quadratic equation, okay, an equation like x square plus 3x, okay, a quadratic equation like x square plus 3x minus 10 equal to 0. There are three different ways that we will learn in this chapter. Okay, the very first form is uh, by the factorization, but we will learn about all of this. But first understand, if I say, okay, that for this quadratic equation, I somehow know that the roots is x is equal to 2, okay, and x is equal to 5. Then what that exactly means at that point? That means that when we put x is equal to 2 in this equation, okay, then my LHS should be equal to my RHS, that is 0 in this case. Yes, let's try. Is it? Yes. So it is satisfying the equation. My LHS is equal to RHS, and hence x is equal to 2 is a solution. Whereas, let's put minus 5 and check it. So minus 5 square plus 3 into minus 5 minus 10. When I solve this, I got 25 minus 15 minus 10, which is exactly equal to 25 minus 25 equal to 0. So talking about this, in both the cases, my LHS is equal to my RHS. And hence, I can say that these two are the roots of the equation. Now, there are various words that we use, we may say that these are the roots of the equation, or these are the solutions of the equation, okay, or this particular point satisfies the equation, right? Okay. Now, as I said, there may be three cases. In this first case, we have explored that a quadratic equation has two real roots, that is x is equal to 2 and x is equal to -5. But I told that there can be two roots, there can be one roots. So let's explore a one root equation. Okay, an equation in which we have only one real root. Okay, the word real is very important because we will learn about that thing. So as we have learned, if you remember, there are domains of number, right? The natural numbers, the rational numbers, the real numbers. Okay, so we are just talking about the domain of real number for now. So let's take another example. Okay, x square plus 2x plus 1 equal to 0. Now, what it means at this point? And for this particular equation, okay, we will know how to find out the roots, but let's say x is equal to -1 is the only root. Now, why I say this? Because except x is equal to -1, okay, there is no other root which is actually satisfying, no other real root, okay, which is actually satisfying this equation to be x is equal to 0. You can try, okay? Now, and when I talk about no real root, so yes, is it possible that we have no one real roots? Yes. We have an equation example of no real roots that goes something like this. Okay, for example, x square is equal to x square plus 1 is equal to 0. This is a very epic case because when we move this here, we got x square is equal to -1. Now, can you find a real number such that its square is equal to -1? Do we have such squares which gives us negative numbers? No. That's the reason this particular equation is not possible in real numbers. Okay, in real domain, this is not possible. Do we have a solution? Of course, we have a solution. We will talk about this later. Okay, now, talking about how to solve this particular equations. Okay, so the moment I say this thing, okay, yes, the moment I say this thing, we have three different ways of solving a quadratic equation. Okay, first of all, let's just write the standard form of the quadratic equation again. It's ax square plus bx plus c equal to 0, where strictly a is not equal to 0. Okay, so there are three types. The first type is when we solve it by the factorization method, by the method of factorization. Now, what is factorization? This is a method. Okay, so I'll talk about the next two methods in a while. Okay, but the first method is factorization. Okay, the second is completing a square, and the third one is the formula method. So completing the square method, and the third is the formula method that we will learn. And mind that each method is used for a specific case. Okay, what it means, although these all three methods works, right? But in different cases, okay, as and when needed, we use this method. Therefore, it is very important to actually learn all the three methods and apply once where it is used. Okay, so the very first method for solving the equations is the factorization method. Okay, now what it says. So for solving this, we have to apply the null factor law. What is null factor law? Just comes again. Okay, there is an important part of null factor law. So the null factor law talks about when the product of two or more numbers is 0, then at least one of them must be 0. What it means? That it means that if, let's say, that I have two numbers as a product, A cross B, right? Now, if A cross B is 0, then what it means? It really means that either A is equal to 0 or B is equal to 0. Perfect. Is it like, can you imagine of a case where it is like the product is 0, but either of the numbers is not 0? Is it possible? No, it is not possible. So that's simple. That is known as the null factor law. Okay. Now, to solve the quadratic equation by factorization method, okay, the very first thing is that you have to make your equation in whichever form the equation is. You have to make the equation in this standard form, that is ax squared plus bx plus c is equal to 0. Then you have to fully factorize the other side. Usually, okay, now because you have already arranged your equation in this particular format, so that side would be the left hand side. Okay, you will fully factorize the left hand side, okay, and simplify it. Now you have to apply the null factor law and solve the resulting linear equation. Okay, so let's do one thing. Okay, let's try with one example here. Okay, have the very basic example of x squared is equal to 3x. Now, as I said, in this particular equation, you have to make this in the standard form, right? So for doing that, I will take minus 3x on the other side, making my RHS is equal to 0. The moment the RHS becomes 0, okay, now I have to factorize it. Okay, so when I factorize it, what I can take common is, I can take x common here. What is left inside is x minus 3 equal to 0. Now, at this stage, I have to apply the null factor law. Okay, so at this first stage, I make RHS is equal to 0. The second stage, I factorized. Okay, and third stage, I have to apply the null factor law such that x is equal to 0 or x minus 3 equal to 0. Because like I told that if the product of two particular things is 0, right, that means either of them is absolutely 0. So what is it? So either x is equal to 0 or x minus 3 equal to 0, which actually apply that x is equal to 3. In this way, we get two different values of x. Either x is equal to 0 or x is equal to 3. So these are the two roots of the equation x squared minus 3x is equal to 0. Now, just coming to the final part of this, okay. Sometimes I observe a lot of students doing this mistake, and therefore I wanted to just tell you. So what they do is that the moment they see x squared is equal to 3x, they divide x on both the sides. And then they say, sir, it's x is equal to 3, and we got the answer. But the issue is that the moment when you're doing this, right, okay, you actually lose, okay, you actually lose one solution, that is x is equal to 0. Okay, so generally this equation should have two real roots, but we get only one of them because we missed a step. Okay, we did a step wrong, and therefore keep in mind that we must never cancel a variable. Okay, that is a common factor. Okay, because x is equal to 0 is actually a common factor from both sides. Okay, so for that equation, okay, unless that we know that the factor cannot be 0, there is a special case when it comes. But in general case, please don't try to cancel the variable in the mid step. Always try to take out the common factor, and then we will solve for the consecutive steps. Okay, now I would like to end up this with a final example, okay, of how to factorize for a normal equation in which we have all the three terms present, because in this one we have only two terms present, correct? Let's try with the last one. X squared plus 3x is equal to 28. Okay, x squared plus 3x is equal to 28. So the very first one, we try to make it in the general form like this. Now, the next part of the equation comes is where we try to factorize this. So now my RHS is equal to 0. Okay, so now we try to factorize this. Okay, how we factorize this? We want a number minus 28, right? We want two numbers, A and B, such that On multiplying, they will give me minus 28. And on adding or subtracting, they give me 3. So when can we get 28? The two numbers that give me 28 is 7 and 4. Since 3 is plus, we are taking plus 7 and minus 4. Okay, so the equation comes like this. Plus 7x minus 4x minus 28 equals to 0. That goes on like x plus 7 minus 4, x plus 7 equals to 0, x plus 7 and x minus 4. So basically we got the two products. Now at this step, we have to apply the null factor law. At this stage, we got that x plus 7 equal to 0 or x minus 4 equal to 0. Coming back to x is equal to minus 7 or x is equal to 4. So these are the two zeros. Okay, now see, these are the two zeros or the two roots or the two solutions. Okay, these are the two zeros, root, solution. Basically, they are the three words that are given for the same part, okay, of this given quadratic equation. Okay, so is this clear? So if you want, you can check this by substituting back into the equation if the left-hand side and the right-hand side are satisfying each other. Okay, so with that, I'm ending this class. Thank you. By the way, my name is Neelmani Sri Shasvikinkar, and if you like this, okay, so please support this, okay, by subscribing a channel, okay, and you may find the content in the description. Thank you.